For decades, long-haul trucking has followed one rule. Diesel dominates. Massive fuel tanks, loud engines, endless maintenance, and fuel costs that fluctuate every single month. Now imagine an electric semi-truck that can travel 800 miles on a single charge. No diesel, no transmission, no traditional engine breakdowns. Tesla Semi is now claiming exactly that, and reports suggest mass production is finally beginning. If true, this is not just another electric vehicle update. This would be a direct strike at one of the largest fuel-consuming industries on Earth. But here is the question nobody is asking carefully enough. Is 800 miles realistic? And what does mass production actually mean in Tesla terms? Today we are breaking down whether Tesla Semi is truly destroying rivals, whether 800 miles per charge is engineering reality or marketing ambition, and what large-scale production could mean for the trucking industry. If you want realistic Tesla analysis focused on scale, economics, and real-world impact, make sure you subscribe to the channel right now. We separate industrial facts from viral headlines. Because trucking is not about hype, it is about numbers. Let us begin. Is 800 miles even possible? Let us address the headline directly. 800 miles per charge sounds extreme, especially for a fully loaded Class 8 semi-truck. So how could Tesla even approach that number? First, we need to understand what an 800-mile electric semi actually requires. 1. Battery size reality. A long-haul diesel semi can travel between 1,000 and 2,000 miles on a full tank. To match even half of that with electricity requires an enormous battery pack. Estimates suggest that an 800-mile Tesla Semi could require a battery pack between 900 kilowatt-hours and 1,000 kilowatt-hours. That is roughly 10 times the size of a typical Tesla Model 3 battery. That is massive, but Tesla has already demonstrated high-energy density battery packs in heavy-duty testing units. The key question is weight, because in trucking, weight equals cargo capacity, and cargo capacity equals profit. If the battery is too heavy, fleet operators lose payload efficiency. Tesla claims its design compensates through aerodynamic efficiency and lightweight structural integration, but the trade-off is real. 2. Aerodynamics matter more than people think. Unlike passenger vehicles, semi-trucks face massive aerodynamic drag. Tesla designed the Semi with smooth front profile, narrower frontal area, central driver position, reduced air turbulence. At highway speeds, aerodynamic drag is the dominant energy drain. Improving drag coefficient by even small percentages dramatically extends range. This is how Tesla can push toward higher mileage without simply adding more battery weight. 3. Real-world range versus marketing range. Now here is the critical distinction. 800 miles likely represents ideal highway conditions, moderate load, controlled driving speed, optimized weather conditions. Real-world trucking includes heavy loads, steep elevation, wind resistance, traffic conditions. So while 800 miles may be technically achievable, average operational range may vary. This does not make it fake. It makes it situational. Now here is the bigger question. If Tesla can consistently deliver 600 to 800 miles under realistic conditions, what does that do to diesel economics? Before we break down cost per mile comparisons, take a moment to subscribe if you have not already. We are about to move into the financial math that determines whether Tesla Semi truly destroys rivals. The cost per mile war. Now we move to the real battlefield. Not range, not acceleration, cost per mile. Because fleet operators do not buy trucks based on excitement. They buy based on total operating cost. Let us break it down clearly. 1. Diesel cost reality. A traditional long-haul diesel semi typically consumes fuel at a rate of about 6 to 8 miles per gallon. If diesel costs $4 per gallon, that equals roughly 50 to 65 cents per mile in fuel alone. Now add engine maintenance, oil changes, transmission servicing, emissions system repairs, brake replacements. Over hundreds of thousands of miles, maintenance becomes extremely expensive. Diesel engines are complex machines with thousands of moving parts, and complexity increases long-term cost. 2. Electric cost per mile. Electric trucks eliminate oil changes, transmission systems, exhaust systems, complex engine maintenance. Electric motors have far fewer moving parts. Energy cost is also different. If commercial electricity rates average around 15 cents per kilowatt hour, and Tesla Semi consumes approximately 2 kilowatt hours per mile under heavy load, energy cost per mile could land around 30 cents. Even if that estimate rises slightly under heavy conditions, electric cost per mile could still undercut diesel significantly. And that is before considering regenerative braking savings in urban routes. 3. Maintenance advantage. Fleet operators care about uptime. Electric drivetrains generally experience fewer mechanical breakdowns compared to diesel engines. Fewer breakdowns mean less downtime, fewer repair bills, more predictable operations. Predictability is valuable in logistics. If Tesla Semi reduces maintenance variability, that alone can justify adoption. Now pause for a moment. If a fleet operating 100 trucks saves even 20 cents per mile over 100,000 miles per truck per year, that becomes millions in annual savings. This is why range matters. Because higher range means fewer charging interruptions. And fewer interruptions preserve operational efficiency. Before we move into mass production claims, ask yourself this. If Tesla can truly deliver lower cost per mile consistently, how long can diesel dominance realistically survive? If this breakdown is helping you understand the economics behind the headlines, make sure you subscribe. The next section will address whether mass production has truly started or whether we are still in limited rollout phase. Has mass production really started? Now we need to slow down and define something carefully. When headlines say mass production has started, what does that actually mean? Because in the automotive industry, mass production has a very specific meaning. It does not mean a few dozen pilot units, limited fleet testing, early customer trials. True mass production means high-volume assembly lines, standardized manufacturing, scaled battery supply, dedicated production facilities, repeatable output at thousands of units per year. So where does Tesla Semi stand right now? 1. Pilot production versus true scale. Tesla has already delivered limited batches of semi-trucks to companies like Pepsi for real-world testing. That proves the truck works. It proves the range is viable under certain conditions. It proves fleet integration is possible. But pilot deliveries are not the same as industrial-scale production. True mass production requires dedicated 4680 battery supply at enormous volume, heavy-duty charging infrastructure, stable component sourcing, high-throughput assembly lines. Building passenger vehicles at scale is already complex. Heavy electric trucks multiply that complexity. 2. The 4680 bottleneck. One of the biggest factors behind semi-scaling is battery availability. A single semi-battery pack could equal the battery capacity of 10 passenger cars. If Tesla wants to produce 10,000 semis per year, battery demand becomes enormous. That requires stable 4,680 output, high yield rates, massive cell production. Tesla has been improving 4,680 scaling, but the Semi program competes with passenger vehicles for battery allocation. Until battery supply dramatically increases, Semi production remains constrained. 3. Charging infrastructure reality. An 800-mile truck is powerful, but trucks need fast charging between routes. Tesla's Megacharger network must expand significantly for true national scale. Fleet operators need reliable high-power charging stations at distribution centers, logistics hubs, interstate corridors. Infrastructure scaling takes time, and infrastructure is often the silent limiter of adoption. Now here is the balanced reality. Tesla Semi is not vaporware. It is operational, but full industrial mass production is likely still ramping, not fully matured. That distinction matters, because once scale truly begins, competitive pressure increases dramatically. Before we move into how rivals respond, take a moment to like this video and subscribe if you value balanced analysis. The next section will explore whether traditional truck manufacturers can realistically compete. Can rivals actually compete? Now we reach the competitive battlefield. If Tesla Semi truly delivers, 600 to 800 miles of range, lower cost per mile, reduced maintenance, growing charging infrastructure. Can traditional truck manufacturers realistically keep up? Let us examine this calmly. 1. Legacy manufacturers are not standing still. Companies like Daimler, Volvo, and Freightliner are already investing in electric trucks. They understand the shift is coming. However, most competitors currently offer shorter-range electric trucks, regional haul focus, slower charging capability, limited battery scale. Many traditional manufacturers still rely on diesel profit margins, existing service networks, incremental upgrades rather than full redesign. Tesla, on the other hand, built the Semi as a clean-sheet electric platform from day one. That difference matters. Legacy brands must protect diesel revenue while transitioning. Tesla does not. 2. Software advantage. Tesla's competitive edge is not just hardware. It is software integration. Tesla Semi can potentially integrate fleet-level energy management, route optimization software, real-time efficiency analytics, over-the-air updates. If Tesla applies the same software iteration speed used in passenger vehicles, Semi performance could improve over time without physical redesign. Traditional truck manufacturers move slower in software development cycles. That gap could widen. 3. Vertical energy ecosystem. Tesla does not only sell trucks. It sells megachargers, energy storage systems, solar generation, grid stabilization solutions. That ecosystem matters for fleet operators. Instead of buying trucks from one company and charging infrastructure from another, Tesla can offer a unified solution. Unified solutions reduce integration friction. And in logistics, friction equals cost. Now here is the strategic reality. Legacy truck manufacturers have decades of relationships with fleet operators. They have service networks everywhere. They understand trucking culture deeply. Tesla must earn that trust. But if Tesla proves consistent uptime, lower cost per mile, and scalable production, economic pressure will force adoption. Trucking is not emotional. It is mathematical. Before we close, think about this. If Tesla Semi truly reduces cost per mile across millions of miles, how long can diesel maintain dominance? Now let us bring this discussion together clearly. Is Tesla Semi really destroying rivals? Now let us bring everything together. Is Tesla Semi truly destroying rivals? Or is this still early-stage disruption? The honest answer is this. The destruction does not happen overnight. It happens through economics. The real weapon is cost stability. Diesel trucking depends on fuel price volatility, engine maintenance cycles, emissions compliance systems, complex mechanical servicing. Electric trucking depends on battery efficiency, electricity pricing, software optimization, charging infrastructure. If Tesla Semi consistently delivers lower cost per mile, fewer breakdowns, and higher uptime, fleet managers will follow the numbers. Not the brand, not the hype, the numbers. And when numbers favor electric, adoption becomes inevitable. The 800-mile psychological barrier. 800 miles is not just a statistic. It removes range anxiety from long-haul logistics. It allows full-day routes without mid-shift charging, flexible scheduling, reduced downtime planning, more predictable delivery windows. Even if real-world range averages slightly lower under heavy load, crossing the psychological 600 to 800-mile threshold is massive. It shifts perception, and perception shifts industry confidence. Mass production is the final trigger. Pilot trucks prove capability. True high-volume production proves dominance. Once Tesla Semi reaches stable battery supply, dedicated high-output lines, nationwide megacharger expansion, thousands of annual deliveries, competitive pressure accelerates. Rivals will not disappear, but diesel dominance weakens, and electric market share grows. The real disruption. Tesla Semi does not need to eliminate diesel overnight. It only needs to win high-efficiency routes first, then expand gradually. This is how disruption actually works. One cost advantage at a time, one fleet at a time, until the tipping point arrives. Now I want your honest opinion. Do you believe electric semis will dominate long-haul trucking within 10 years? Or do you think diesel will remain king longer than expected? Comment below and let us discuss. If you value realistic Tesla analysis focused on economics and industrial scale, subscribe and turn on notifications so you do not miss our next deep dive. And in the next video, we are going to analyze whether Tesla's Megacharger network could become the most important energy infrastructure build-out of this decade. Thank you for watching. Drive smart, think long-term, and I will see you in the next one.